Hey everyone, and welcome to the AI Research Roundup. I'm your host Alex, and today we're diving into some fascinating work on AI memory. We'll be looking at a paper titled ZEP, a temporal knowledge graph architecture for agent memory. Basically, the researchers introduced ZEP, which is a new kind of memory system for AI agents. It's designed to go beyond just static documents, which current systems often rely on. ZEP uses something called a temporally aware knowledge graph engine to dynamically pull together information from ongoing conversations and even structured business data, all while keeping track of how things relate over time. They show it outperforms the current state-of-the-art, MEM-GPT, on a key benchmark, and really shines in more complex, real-world-like evaluations. So diving into the actual results, this first table shows performance on that deep memory retrieval benchmark I mentioned, the DMR. It compares ZEP against other methods like MEM-GPT and just using conversation summaries or the full conversation history, using both GPT-4 Turbo and the newer GPT-4o mini model. You can see ZEP consistently gets the highest scores. With GPT-4 Turbo, ZEP hits 94.8% accuracy, just edging out MEM-GPT and the full conversation baseline. And with GPT-4o mini, ZEP reaches 98.2%, again slightly better than feeding the whole conversation in. So on this benchmark at least, ZEP really holds its own. But the researchers felt that DMR benchmark was a bit limited, especially for real-world enterprise-type tasks. So they also tested ZEP on a new, more challenging benchmark they created, called Long Mem Eval. This table shows those results. Here again they compare ZEP against just feeding the full conversation context to the model, using both GPT-4o mini and the full GPT-4o. And, well, you can see ZEP gives a really nice boost in the accuracy score for both models. But look at the latency and context tokens. ZEP cuts latency by about 90%, from around 30 seconds down to just 3, and uses way fewer tokens, only 1.6 thousand compared to 115,000. So ZEP really shines here, being faster, cheaper, and more accurate on these tougher evaluations. So digging a bit deeper into those long Mem Eval results, this table breaks down the performance by the type of question asked. You can see ZEP really boosts accuracy on certain kinds, particularly things like single session preference and temporal reasoning. For instance, with GPT-4o, ZEP improves preference questions by a massive 184%, and temporal reasoning by over 38%. Interestingly, it does seem to dip slightly on single session assistant questions. This suggests ZEP is especially helpful for the more complex memory tasks involving preferences or time. So yeah, ZEP seems particularly strong on those tricky memory tasks. Overall, this work presents a really promising architecture. Using that temporal knowledge graph makes agent memory much more efficient and accurate, especially for complex long-term interactions. This is super important as we try to build more capable agents that aren't limited by context window size. It really helps tackle that long context challenge. Well, that's all for this episode of the AI Research Roundup. Thanks for tuning in. I'm your host, Alex.